Alright, so this is the second video of lesson 3 in unit 5 here, and we are done with the notes part. So let's look at some of the examples on completing the square. I am going to do the example down here in the lower right corner because I do want to go through each of the 6 steps, or at least the first 5 here. But anyways, I'd like to go through all the steps and have room for it. So that's what we're going to do here. That's good enough. So I'm going to just start with step 1. So I'm numbering these as the steps, not as which problem I'm working on. But anyways, the first step literally just says group them together, and well, frankly, we don't have a whole lot other than the x terms, but I'll still do it. So x squared minus 6x, and group those in parentheses. Step 2 does say that we are going to factor the a out of each term in parentheses. Well, step 2, we don't really have a coefficient in front of the x squared. So I'm going to mark step 2 and then say no change, just again for the video. Step 3 asks us to add half of the x coefficient squared in parentheses. So in parentheses, so here's our x squared minus 6x. And then it says take half of that x coefficient, so half of this term squared. So half of 6 is 3, so in fact I will even say plus 3 squared. I will leave it as that and not as the number 9 yet. Alright, step 4, what do we have? Step 4, now we go ahead and subtract the equivalent amount outside of the parentheses. So we have x squared minus 6x and looks good. Okay, step 5. Well, hold on. Let's take a pause here. Why do we do this step? Why is step 4 so important that we get it done and we get the right signage? Well, the reason is we started with x squared minus 6x. In order to make this thing work, we can't just arbitrarily say, oh, hey, by the way, we're going to subtract 9 now, because then we have a different equation, we have a different graph, all this stuff. So we can't just simply add 9 inside the parentheses. We can't just subtract 9. But together, by adding 9 inside, we are not going to get the same graph unless we negate that 9 somewhere else. So in step 3, we are introducing this plus 9. In step 4, we're saying, hey, let's get rid of the 9 in a way. If you simplify this out, x squared minus 6x plus 9 minus 9 still reduces to x squared minus 6x, which is what we started with. But in the way that we're writing this and leaving them separate, you'll see how that works to our advantage while not messing up the original equation. In step 5, it says write as a perfect square and simplify. So in step 5, we are simply writing the parentheses stuff as a perfect square. Oops, sorry about that. As a perfect square, like I said, and really all that means is instead of writing this x squared, 6x, and 9, we're going to write it as best we can, as simple as we can. And if you were to factor, if I just said, hey, factor this this form right here, x squared, 6x, and 9, you would look at that and say, well, I should be able to take both. So I'm going to have 2 sets of parentheses here. We got x and x. That'll give our x squareds together. Now, when I see the x with a plus at the end, that means that the signs for each of these binomials will be the same sign. What sign is it going to be? It's going to be the same as this sign here. So all that means is I'm writing it as x minus a number and x minus a number. And I'm trying to find what 2 numbers will add together to 6, but multiply together to 9. And the answer is 3. So just factoring this as a general form, hey, factor this formula, you would get x minus 3 times x minus 3. But step 5 is saying write it as a perfect square. And a perfect square is exactly that. It's x minus 3 times x minus 3. So we would write it as x minus 3 quantity squared. Okay, so that's just what's inside the parentheses though. So we still have minus 9. Because again, if you expand x minus 3 squared, if you expand it out, we get this whole thing, which is not what we started with. So we have to say the x minus 3 quantity squared, and then still minus 9. There you have it. We completed our first square. Congratulations. I am going to go ahead and do one more problem. Looks like I did number 5. So number 5, I'll change color here. What do you say we do orange? Sure. Make it stand out. So here's number 5. So let me go back. And number 1 goes down here. Okay. Here we go. So number 5, we do have a few extra steps. So in number 5, we start with step 1. We group just the x and x terms together. So we add the parentheses. The thing is, it doesn't really matter in this case because we don't have anything else going on. You'll see later when I do the next video, the parentheses do matter at some point. Okay, step 2. What does step 2 say? Step 2 says factor the a out of the term in terms of like the example a times x squared plus b. Okay, so basically factor out the leading coefficient. So 3 times the quantity, x squared. Now it's minus 5x now, plus 27, right? Because we factored a 3 out. If we redistribute, 3 times x squared gets us what we want. 3 times 5x gets us what we want. Step 3, add half of the x coefficient squared in parentheses. Okay, so we rewrite 3 x squared minus 5x. This is where we take half of this term, so 5 halves. We're going to add half of the coefficient squared inside the parentheses plus 27. Okay, step 4. We get even more room here. Step 4, we want to subtract the equivalent amount outside the parentheses. Okay, so now we've got 3 Okay, now this is where we got to be careful. Minus 3 times the 5 half squared. So let's see what happened, right? We took a 3 times x squared, 3 times the 5x. We were trying to get this original 3x squared, 15x. We then took and added half of this coefficient squared, but we did it inside parentheses that were times 3. So when we say that we added 5 half squared, we don't, like in this example, we don't just say we subtract that 1/2 of this coefficient squared. We don't just say we subtract 9. That was because there was a 1 coefficient here. We were able to do that. Here we want to take 3 times the 5 half squared, because eventually if I distribute things out, that will allow those two numbers to cancel. When we go to simplify this, just like this, here I'll write it as, move it too far ahead. 3 times x minus, so remember we're writing step 5 here now. Sorry, I kind of skipped ahead to that. Write it as a perfect square and simplify. Well, writing it as a perfect square, here's your perfect square written out. So when we go to factor a term like this, we have a plus at the end, so both signs are equal, and they are both a minus sign because this is a minus here. So again, it's x minus and then it's half of your x coefficient, so half of 5. So we write it as x minus 5 halves squared, 3 times that quantity. Now, plus, what do we got here at the end? We got plus 27 minus 3 times 5 half squared. So, 27, I'm going to come up here and try and simplify that. Minus 3 times, I'll at least get rid of the squared, right? We'll distribute that out. So really that's, why am I going to, so I should probably do some simplifying in this step. So 75 fourths. So 27 in fourths, that's 108 fourths. Minus 75 fourths gives you 33 fourths. So plus. And there you go. That is your simplified version of your completed square. There you go. 11 minutes. Sorry, that went kind of long, but I did want to walk through and explain a lot of what happened and why, not just do the problem. So there you go. Next video up, I will be doing the practice problem examples. I will be doing the examples from the notes rather than practice problems. So I'll probably, again, do at least 2 of these, maybe 3 of these in the next video, where we actually have x terms, y squared terms, all the good stuff, coefficients, all that. So thanks for watching, and we'll see you in the next video.